Welcome to Learning to Engineer. In this video, we will solve some problems in the concept of inverting and non-inverting amplifiers and some arithmetic circuits that are based on it. Something like integrators, differentiators, adders and subtractors. Okay, so we saw the basic concepts about operational amplifier in this video, and we also saw the equivalent circuit of operational amplifier. We analyzed the DC part and the AC part separately in these two videos. Okay, so now we are going to see some problems in this concept. Let's get started. In an inverting amplifier, the power supply is given to the inverting terminal or the negative terminal. The positive terminal is grounded and this acts like a virtual ground. Okay, what is virtual ground? It means that the 0 volt is applied to this and the same volt appears across this too. This is the ideal case. Okay, in the non-inverting terminal, the power supply is given to the plus input or the non-inverting input, and the inverting input is grounded here. Okay, so the basic difference between both of them is where the power supply is present. Sometimes what will happen is this resistor will be present in the negative part and power supply will be given to this, or the feedback resistor will be connected to the inverting terminal but the power supply will be connected to the positive. We will see all those cases in the problems that are going to come. Okay, so for now the formula for output voltage is the gain times the input. Okay, because this is just an amplifier, we are going to amplify this input and this amplification happens based on the amplification gain AV. Okay, so which is equal to the negative of RF divided by R1 times the input voltage Vin. Okay, but for the non-inverting case, the output voltage will be 1 plus RF divided by R1 into Vin. Please make a note of this formula. We are going to use this to solve the problems. Okay, the first question is, it's very simple. We will be given the values of RF and R1 and we have to find out the value of output voltage. For the circuit shown in the figure, find out the output voltage. In the given figure, the value of R1 is given as 30 kilo ohm and the value of RF is given as 300 kilo ohm. Okay, so the input voltage is equal to 0.2 volt. The output voltage is equal to the negative of RF, which is 300 kilo ohm, divided by 30 kilo ohm Rin times the input 0.2 volt. So the output voltage will be minus 2 volt in this case. So for the same circuit, if this supply is present in the non-inverting, you have to use this formula, which is 1 plus 300 kilo ohm divided by 30 kilo ohm times the input 0.2. Okay, so the answer will be 1 plus 10 is 11. 11 into 0.2 will be 2.2 volt. So for the same input and the same resistors, the value of inverting configuration is minus 2 volt and the value of the output at non-inverting will be plus 2.2 volt. Okay, so this is just a very basic problems to start with. Okay, now we will see a little trickier problem where we will understand the design of the amplifier as a whole. Okay, so from this formula, which is the output is the negative of RF by R1 times the value of the input Vin. Okay, so we understand that the output is directly proportional to RF and it is inversely proportional to R1. So for that reason, can we have R1 to be very less? Is that fine? Will the circuit work fine? No, because for a small signal analysis, when we do of any circuit, we want the device to have as much input resistance as possible. Okay, so for that case, if we have R1 to be very high, for the a reason of having a better input impedance, what will happen to the amplification output? It's going to be less. So it has to be less, but it should not be very less. Okay, so there should be a median. We have to choose between the two. Okay, so let's see one problem to understand this concept better. In the given inverting amplifier, we need to design the input resistance to be as large as possible, but the gain should be within -10 and -25. The upper limit on RF is 1 mega ohm. What is the value of R1? They want the input resistance to be as high as possible. So can we just put infinity? No, practically that's not possible, right? So in the given options, we have option B, which is 1 mega ohm, which is same as that of RF. What is RF? RF is given as 1 mega ohm. When R1 is also 1 mega ohm, there won't be any amplification. It will just be an inverter. If you supply plus 5 volt, for example, the output will be minus 5 volt. So what's the purpose of the amplifier here? So option B also doesn't hold good. Okay. So compared to option C and D, we see that option C is 100 kilo ohm, which is larger than option D. So can we simply say that option C is the right answer, because they want the input resistance to be as large as possible? Let's find out the gain and check if we can have the input resistance as 100 kilo ohm. RF is given as 1 mega ohm, and we have to find out this to match the gain of -10 to -25. Okay, so when we say that the gain is -10, what should be the value of R1? Minus RF by R1 is equal to -10. So this implies that RF is 1 mega ohm. Okay, so 1 mega ohm divided by R1 should be equal to 10. So in this case, what is the value of R1? 1 into 10 to the power of 6, which is 1 mega ohm, divided by 10, which is 10 to the power of 5 ohm, or this is 100 kilo ohm. Okay, so the gain requirements also satisfied for option C. Let's check out option D too. Okay, so in option D, what happens? So when the gain is given as 25, what should be the value of R1? This implies that R1 is equal to 1 into 10 to the power of 6 divided by 25. So R1 is equal to 40 kilo ohm. So now the R1 is 40 kilo ohm when we have the gain to be 25, but if the gain is reduced to a little bit, we get -10, but the input resistance is as large as possible, which is the design criteria over here. So which one can we choose? We have to choose option C. This is because we are satisfying the gain requirements also. Even though the gain is less, the input resistance is larger. Okay, so it satisfies both the criteria. The gain should also be within the design limits, plus the input resistance should also be as high as possible. So we are going with option C, which is 100 kilo ohm. Okay, which is slightly less. This is 10 power 6, and the RF value is 10 to the power of 6 and R1 is 10 to the power of 5. Okay, so when RF and R1, there is a wide gap between the RF and R1, we will get a higher value of gain, but the R1 value should also not be very less, so that it doesn't satisfy the design requirement. Okay, so from this problem, we understood one thing, that R1 should be as high as possible, still it should satisfy the gain requirements of the amplifier. Now we will see another problem. In this question, we have to find out the gain range of this amplifier. First thing is this an inverting amplifier or a non-inverting amplifier? We have the input connected to the positive terminal, but there is a feedback to the resistor which is present at the negative terminal. Still, this is a non-inverting amplifier because power supply is applied to the positive terminal. So this is a non-inverting amplifier. We have to substitute the formula and find out the gain range. Okay, this is a adjustable resistor. Its value ranges from 0 to 10 kilo ohm. So this setup has a resistance of 10 kilo ohm to 20 kilo ohm. Okay, because the range of this is 0 to 10 kilo ohm. Okay, so the input Rn or R1, let's say. So R1 ranges from 10 kilo ohm to 20 kilo ohm, because both of them are in series. The least value is 0, the highest value is 10. So it is 10 plus 10, 20 on the higher side. Okay. So what is the gain? Let's say AV1, which is equal to 1 plus RF by R1, okay, which is equal to 1 plus 200 kilo ohm divided by what is the value of the minimum resistance, 10 kilo ohm. This is 21. So what is AV2? 1 plus RF by R2, let us say. Here R2 is 20 kilo ohm, which is 1 plus 200K divided by 20 kilo ohm. So the gain is 11. Now we have understood one more concept here, that when the input resistance increases from 10 to 20, the gain reduces. Okay, so the gain ranges from 11 to 21 based on the value of this input resistor. Okay, so if you want a higher amplification, the volume control or the amplification control is placed at the input resistor. Okay, now we will solve another problem. This is a cascaded amplifier where we have 3 amplifiers over here. This is a non-inverting amplifier, this is an inverting amplifier, and this is called as a unity follower, where the input voltage is 0.2 volt. The output at a unity follower is the same as the input, which is 0.2 volt. Okay, the follower has a feedback loop which is connected to the inverting terminal, and the power supply is connected to the non-inverting terminal. So the input which appears is 0.2 volt across both these transistors. Let us call this as amplifier number 2 and this as amplifier number 3. Okay, so we have V2 and V3 separately in this case, where 0.2 volt is the inverting input, where 0.2 volt is the non-inverting input and 0.2 volt is the inverting input in this case. So what is V3? What is V2? It's same, but just that they have the they both have the same value of the input voltage. So what is V3? V3 will be minus RF divided by R1 times Vn, okay, which is equal to minus 200K divided by 20K times the input 0.2. So what is the value of V3? V3 is equal to minus 2 volt. What is V2? V2 is equal to 1 plus RF divided by R1 multiplied by Vn, which is equal to 1 plus 200 divided by 10 multiplied by 0.2. There is no space. Okay, I have just written it on the top. So what is the value of V2? The value of V2 is equal to 1 plus 200 divided by 10 is 20 multiplied by the input 0.2, which is equal to 21 into 0.2, which is 4.2 volt. Okay, so this is also a very basic problem in the concept of inverting and non-inverting amplifier. So V2 is 4.2 volt and V3 is minus 2 volt. In this video, we solved some simple problems in the concept of inverting and non-inverting amplifiers. We saw a cascaded problem too. Next, we will see some arithmetic circuits which are designed based on operational amplifiers. We will also see some problems for the same. Okay, so thanks for watching. If you have any doubts, do let me know in the comment section or give a thumbs up if you like this video. Thank you.